How's it going, everyone? Eulier Gonzalez. That's right. Okay, so let's going to explore now this hard part of Node, a course taught by Will Sentence, the CEO of Codesmiths. This code or bootcamp that is now on LA, New York, and UK. Where the idea of this particular course is to understand now the inner mechanism of Node and how now Node plays a role in the entire web development or in the entire web applications. So by looking at how now service works and how now they fit into this communication on the internet, right? Client and server, and understand now the nature of this communication that happening among this two computers over HTTP, and understand now how JavaScript work in order to control now through C++ computer internal features such as the file system, the network, the encryptions, and that also to understand now is the JavaScript engine in itself. All right, what is a threat? What is the anatomy of the JavaScript, and also look at the things that we can do in Node.js, such as working with the streams, and how can we now deal with errors here. And I think this is something that is very, very interesting in terms of not only on academic stuff but also in the more practical sense, because the idea of this series of videos is to understand now the fundamentals, have a mental model, so anytime we need a particular feature, we don't need to memorize all of this. We need to know where to look at it. That's all. So by having now this mental model, this visualization, this diagram in our mind, and understand how these things work, we can now are able to write we're now able to write is effective servers, therefore reducing is the cost of running a business. So let's get into this. So to understand this briefly, this is just mostly to understand, this is just to describe is now what are the stuff that any company are looking for. Or if you are now a company, so you're looking is you want to hire a candidate, this is what you are looking for, right? Hey, someone that can now solve and have analytical problems and problem solving skills, coding, communications, in technical. So it is that person memorized that or it knows a trade-off. In all of that is just to make now sense when it comes to provide a particular feature, because the difference between the junior and the mid and the senior is that now a junior doesn't know how to do, doesn't know how that stuff works, but it will find out a way to actually do that. Whereas a mid-level, it knows how that things work, and it trying to give you now is the solution as fast as possible, but doesn't know is the overall perspective. In other words, the bigger picture of why we're doing the stuff that we need to do. Whereas a senior developers, it makes sense and provide meaning to others by now building this kind of applications. So on that topic, all right, this course is now organized in this. This is the introduction as a way to understand now Node fits into our own web applications, and we need to ask questions like, what is a web application? Which is now a application that is running on a browser, whether it is on Michael's or Rich or Seth devices, Mac, Linux, or a mobile phone. All of this is now run using code, HTML for structure, CSS for prefix stuff, and JavaScript. So provide now interactivity to this particular document that the browser is rendered. Now, because with JavaScript, this is now a language that is working on the browser only, and when you want to now send message to another computer, or in the case a server, those servers are written in a particular language, whether it's PHP, Ruby, Java, Python, and also JavaScript. What happened is that since JavaScript is a very powerful scripted language, it doesn't have access natively to the computer's internal features. That's when now Node kicks in. So now Node, this particular layer that we have here, okay, so this is the computer that is going to send now a message to this. As you can imagine, this is the Twitter computers, all right, but it's going to receive that, and that needs to be received over the physical medium, over the network card. But because JavaScript doesn't have access to these internal computer features, all right, whether it's reading the file of assistance or accessing to the hardware, for example, the network card. So we need to have some sort of adapter or hook that allows us to actually, from JavaScript, communicate through that. So that's what Node actually does. It exposes you a certain labels that allow you to control is some of the internal computer some of the internal computer features. Okay, so for example, file system, network, cryptography, and so here we are describing is what needs to be done in order to happen and understand not necessarily the C++ code, because after all this is not a course about that. We don't need to know how to write C and C++ code. We just want to know is what is the mental model, the visualization, this diagram, this series of process, a series of flows that happen behind the scenes anytime that we now call is one of those labels from JavaScript. That therefore is now communicating to C++, and therefore allowing to access to these internal computer features. All right, so for that, holy moly. So for that, we need to know as how the JavaScript works. There are a couple of things that we need to know. Is that how JavaScript works, the HTTP, this sending. Let's gonna start with at least from receiving the message to now processing that. So first we need to know is, this is not a particular order, but we need to know is how we receive and send message through the HTTP, all right, and then now how those messages actually are transformed, and then now how can we access to those message or internal features from Node, which is written in C and C++, that now expose that to the JavaScript world so we can have access to. So in other words, we need to understand now how JavaScript works, this machine, this engine, how the things work, as well as the mental model of the node bindings, That's why now actually you should call this is no C++ features, as a way to now be more descriptive about what Node.js is all about. It's just it's just CSS code that allows you to now communicate with these internal computer features. And this is exactly what we're going to talk about here. So, first, what JavaScript does? Well, it do a couple of stuff. It do the three main stuff. It allows to save variables, it allows to save data, and it is functionality to be later on, okay, to be used later on, and then use that data by running the functionality on it, okay, and allows to access some of these platform-specific APIs. So in other words, whether it is the browser or Node. So it has tons of labels, all right, that allows to access this computer features via C++ bindings. And this is interesting. This is huge, because if again, the whole point of describing this is to create now this narrative as a way to understand and therefore make it meaningful to others. Here we look at the two things that we can do in JavaScript, all right, which is saving data and its functionality, and then use that data by running a functionality on that, all right, and then store that. Similar here, and then we can have access to now the browser features or the platform-specific feature, whether it's on the browser or no. So that's exactly what we're going to talk about in this video. Bear with me. Yeah, really? Okay. Okay.
Let's see these first two in action. Here we go, people. JavaScript does two things. One, it saves stuff to a little data store within JavaScript, a little store of data. What do they call the store of data in JavaScript itself? Sam, what do they call the store of
Heap.
data in JavaScript itself?
Global execution context.
Not quite. What do they call it?
No, the heap. But we have the heap.
Who raised hand, you know what they call it? Yes, go ahead.
The heap.
Well, that's the fancy name. Very nice. What's the trivial name for it? Memory.
Memory.
Exactly. They call it the memory. There you go. Global. It's global, people, because it's available in all of your JavaScript code as it's running. Anything saved in this little store of data will be available the whole time. As opposed to when we run a function, it's going to store up all that data inside the function. Execution context is known, as we'll see in a second. And as soon as that function finishes running, all the data gets deleted. All right. So let's get storing stuff, people. And remember, we're doing this because we better understand how JavaScript runs if we're going to be able to handle
completely.
By before we start the pair programming, you'll have the full model of Node down, sufficient to be able to, in theory, do anything that LinkedIn does with Node, anything that Netflix does, within reason. The fundamental tasks they're doing. By the pair programming, it's only a few days, only a few hours away. Hours away. All right, there you go. What are we doing then? Therefore, at this moment, as JavaScript code kicks off, starts running, what's the first thing it's going to do, Matt?
It's going to evaluate that sentence, and then store that. It's going to store 3 into into a label called num, or into an identifier called num.
It's gonna the first line.
Yeah, that's the worst answer ever, Matt. Matt, what's that first line say to do?
Assign 3 to a variable.
Perfect. Yeah, it is, exactly, to a variable. Num is set to 3. That means we have a label saving data. Next line, Matt, what's it say to do? If you've got it written up there.
It's a comment, but
That's true. Okay, next line, the JavaScript executes.
The function. Let's go into now store the function reference.
Yeah, what does that even mean? Declare, register, define, they all mean the same thing. They mean literally take the function's label and then its body and parameters and save the code. Do not do it now, save it later. Save it like you save a number.
Exactly.
It's not the right word to me. I mean, it's not incorrect. It suggests it's kind of vaguely aware of it. Declare and define suggests it's vaguely aware of it. No, it never is going to go back to this line. So it better hold on to all that data.
Exactly.
It better hold on to it, and it does. Be really clear on that.
So you really store that.
The label, which we gave it, which was what mark.
Exactly. Let's take this label.
Absolutely, and it's taking all
Take this label and store all of its code here.
Parameters they're known as, that are hopefully when we end up wanting to run this code. And how do we run this code later on, Andrew?
We declare we put the variable name with some parentheses.
Perfect.
Exactly.
We execute code by taking its label and putting
Parentheses of that.
Not by inserting arguments. That is a separate thing. We execute code.
Exactly. We execute code by putting in
take
the
code to run
parentheses.
By putting parens on the end of the name of the code that we saved. Perfect. All right. But for now, what's the other thing that goes into executing a function? Well, we ideally want that code to be a little bit more flexible to work with different data. What if we want to say it's going to multiply 3 or 7? So we have placeholders for data that then gets inserted when we go ahead and run that code. Two parts to running a function. One, running its code. The other, inserting actual values as inputs. So when we save the code that's going to later be run, we better have both of those things. Space, code to run. That's the body of the function inside the curly braces. We're storing that in here. That's the body of the function.
We store that.
And we better have little placeholders that are awaiting any data to be inserted. And that's the parameter between the parentheses. Okay, and that's also stored in here.
So it's just explaining is what is the next line of doing. Well, JavaScript is going to evaluate that identifier and execute that as long as it has, and execute this as a function as long as it has the parentheses.
Two things running a function. We better be ready to do both. We better be ready for both of them. It's saved. Next line, Virginia. What's the next line of code we're going to do after we've saved the function multiplied by 2?
More comments, and then and then create a label output. And
Excellent.
Assign it to function.
Not quite.
Or call it, or execute the function.
Aha. Left-hand side first. Declare output is a label. People, this may feel quite trivial when we're here to learn about building LinkedIn from scratch, but I promise you, I have a feeling that if we're going to receive messages at any random time from Sarah Rose's Mac, she wants to get on Twitter anytime, all the time. She's very excited by Twitter. In it comes, that's going to presumably tell Node, because Node can listen in through actual, we'll learn later on, a feature or a library of C++ code called libuv that can be aware when an inbound message arrives. Node is then somehow presumably going to tell JavaScript to run some code to look at that message. Because we want to look at the message. So we want to be able to write code in our language that looks at the message and sees what it's asking for. Well, that sounds like we're going to have to run some code up here later than when we wrote it. How do we bundle up code to run later than when we wrote it? Mohammed, how do I bundle up code?
We're wrapping a function.
So it may seem trivial, people, functions, but they turn out to be the most important construct in JavaScript. Code bundled up that we're not going to run now, we're saving it to run later. And we're going to do a lot of saving code to run later. And by the way, note here, when we run it later, we are going to manually ourselves put the parens on the end to say run it. I manually insert the input known as the argument. I have a sneaking suspicion that Node might end up being the one who puts the parens on the end of our function code, who inserts the input automatically for it. Might end up being the one who puts the parens on the end of our function code, who inserts the input automatically for us. And that's going to turn out to be the entire paradigm of Node. But we'll get to that in a second. For now, let's start off by declaring output. There it is, output, the label is declared. Do we know what to store in it yet, Virginia?
Do we know what to do?
Do you know what to store in output yet?
Not yet, because we haven't executed it.
Spot on. Virginia. So it's going to be uninitialized for now, no actual value. Not undefined, because that's an actual value in JavaScript, meaning if it's a constant, you couldn't then change it from the undefined to whatever the return value from multiplied by 2 is. So it starts as uninitialized completely, no value. And we go ahead and now execute code.
Multiply by 2.
Almost like a mini app. Like a mini JavaScript. This is a JavaScript app. It's got memory and the ability to go through the code line by line.
Which is a
Anyone tell
thread.
me what the ability to go through the code line by line is known as?
Thread.
What's the ability to go through the code line by line known as? Thread of execution. That is JavaScript's ability to thread its way down the page, line by line, and execute the code as it goes. Okay, well, we need the very same two things to run a function. Roman, what am I calling multiply by 2 with?
Function.
What am I calling it with? What input am I calling it with, Sarah Rose? Roman, what am I calling multiply by 2 with?
Function.
What am I calling it with? What input am I calling it
What input? With num. With thread. 3.
For output, you're calling it num.
Which is what value?
3.
3.
3. Excellent. Thank you, Sarah Rose. And now we are going to execute. What's the intuitive meaning of the word execute, William?
You're gonna run it?
Run it. We're going to run the code of multiply by 2. To run code of a function, what do we need? We need a new
Function
context.
Wow. Oh,
Function execution
the movement
context.
is spreading. I mean, the movement is literally just the official words from JavaScript, but in some ways there's a movement. Exactly, an execution context. People, it's just a mini app, like a mini JavaScript app, like the big one we were just
So
did.
anytime you create now a function,
run
you
code,
create it is
place to store stuff that shows up, a memory.
exactly place to store stuff, and the ability to align the execute line.
Little memory, that means
Code line by line.
So this one's temporary. They call it local or temporary. I call it temporary. And it's just for inside this function. And when we leave the function, what keyword makes us leave the function?
Return.
If there's no return, we just leave the function automatically when we hit the closing curly brace. Everything is deleted in here. Okay, so first thing in the local memory set is what? Input number. And it's set to what value?
Right now it's 3.
3. Then we do declare result. It will be 3 by 2, which is 6, and we return the value of result into output and assign it out. There we go, folks. This is the heart of JavaScript. Two things it does: save data and code. Run code on data. What's the first thing it does, Matt? What's the first thing and code? Run code on data. What's the first thing it does, Matt?
Store the value.
What's the first thing it does, Michael?
Store the value.
First thing it does, Virginia? Yes, and code known as functions.
Function.
And the second thing it does,
Okay.
run code on data. What's the first thing it does, Matt?
Oh, save data on memory. Save data and its
First thing
functionality.
it does, Michael? What's the first thing it does, Virginia? Yes, and
Functionality
known as functions.
Functions.
The second thing it does,
is to use that data by running. Use that data by running the functionality on it.
Sam?
Runs it.
Runs code on data. First thing it does, Matt?
Runs code.
Second. Charlie, first thing it does? Saves code and data, correct. Second thing it does?
Runs code.
Runs code. Matt, you are gifted beyond. All right. Now.
You are gifted beyond. You are gifted beyond, man. Oh my god. You are gifted
Let me show you
beyond.
the hard parts. You know it does some interesting things like when you save a function, it bounds it or links it to all the surrounding environment. But basically, it saves data and code and runs that code on the data. That's all it does. But we're the ones who tell it to run the code. By doing what? How do I say to run a function, Charlie?
Passing parentheses to that identifier.
You apply parentheses to it.
And parentheses on the end. Spot on. I just have a feeling that it might be that someone else will put those parentheses on. And it's really the most important part. Let's now see JavaScript's other talents, built-in labels that trigger node features.
The other talents.
Our dream.
The other talent. Exactly. That's another reason.
Look at an incoming message off the internet, introspect it, look into it, see what it's asking for, and then send back right tweets. That's our dream. So there better be a label from in here that accesses or sets up a Node C++ feature that can access the networking feature of our computer. Oh, there better be one. What is it? Well, actually, the main one's called net, but there's a more specialized one called HTTP. The node feature that's going to access the network card effectively and be able to receive messages in the HTTP format. And folks, we're going to see HTTP in more detail, but for now, just know it's the format by which you send messages or requests from a web browser, and whenever you type in a URL and press enter, you send out a message and it's sent out automatically in the HTTP format. Hypertext transfer protocol. Protocol means format of data and rules by how you communicate. Format of data, HT, hypertext.
Exactly, hypertext, which is any way of how you can express now content, whether it is media, image, video, you know? It's pretty weird how you can actually try to construct video on a page. Not on a web page, no. I'm talking about a book. You know, that's what they call here hypermedia.
That's the structure of web pages linked between them. Transfer. It's transfer. Good. And we need to have our network open. We're going to discover we open a socket, which is an open connection to the internet, an open channel for the internet, two-way open channel for the internet. We're going to discover that open connection, we need to have it formatted such that it's ready to receive HTTP formatted messages. How are we going to do that for JavaScript? Via what, Roman?
HTTP.
With C++. Exactly. Most powerful built-in node featureable HTTP, and it's associated built-in label in JavaScript. Everyone gets what I mean by label. It's a label, a word in here that will trigger something down here. That's what HTTP is. Okay, here we go, people. Using HTTP feature of Node to set up an open socket connection to the internet. Socket is the posh word for an open channel for data to go in and out of a place over the internet. People, there's Macefield. I'm going to, I want to build a cool-looking app. Today we use when an invalid label. Let's see a type. That's good. And now.
Oh, give me space, bro. No.
Every single node feature that you ever included. All right. Current rules by how much, and it's sent out automatically.
Okay.
Automatically in the HTTP format. And whenever you type in and now just know it's the format by which you send messages or requests from a web browser. And whenever you type in a URL and press enter, you send out a message and it's sent out automatically in the HTTP format. Hypertext transfer protocol. Protocol means format of data and rules by how you communicate. Format of data, HT, hypertext.
Okay. I just want to bring this up here because executing JavaScript code review, because this is executing. That's one of the reasons why I will love to go back to the root, so we can now at least discuss and refresh how do we get here and a lot of this particular concept to make those trivial stuff are not that trivial at all. That is the reason why they're not so obvious. So executing node code. No, it's executing is JavaScript code review. JavaScript code review. All right. Let's get into this. So let's go to the scribe. Here is the line by line process of evaluating JavaScript code, which is important, right? So let's go to the scribe. Here is the line by line process of evaluating JavaScript code. All right. exactly, of evaluating JavaScript code here. Based on the previous, based on the image above, right? On the image below. All right, good. There you go. So, so first, so line one, JavaScript store the value 3 in on the identifier called num on memory. Okay, so far so good. We can also have now a diagram for that.
And now just know. Here we go, people.
Just a function.
Saving data. Next line math. What's it saying to do? People got it written up there.
It's a copy.
Fine. Look. So it better hold up because what Matt run this code later on, Andrew? Separate thing. And we end up with doing is taking the label, vaguely aware of it, and then it's
Okay, so you got this one. And there you got it. Oh. Exactly. Here in this diagram we have the thread of execution. Okay, this is now the components of JavaScript thread of execution, memory, function execution context, as well as now the call stack. Function execution context. So this is the anatomy of JavaScript. We have now the thread of execution, how it's going to evaluate line after line. Now the place where we're going to store the data on memory, aka called heap. All right. And anytime we now open up a new functionality or a new set of a function, it's going to create now a function execution context. Okay, evaluate all of that. It has its own threads and memory, and by the time that that function is run completely, because this is the behavior by default on functions, runs to completion, then he get out of that, go back to where we was called, and they continue to evaluate that. And in our case, this is now the global execution context. All right. And anytime you want us to now keep track of where you are in the code when you get into a function, so you can go back and continues to evaluate that, then we have the call stack. And to now, the first sum has to be complete at some point in the future. All right. We have now the event loop, where you can put now is stuff on timers, set timeout, set intermediate, on the callback queue. Hey, all of these tasks I want you to now schedule to be later on to be evaluated after I run this file completely, right? So this is the callback queue. And also we have now the micro task queue, which has more priority than the callback queue. That give us now the ability is to add micro tasks or functionality code and queue them with more priority. So for example, when you use a promise, this is the place when you put all of this set of instructions with more priority than the callback. You want that JavaScript via the event loop execute that after you evaluating that particular code. This is quite interesting to understand this entire narrative and description for that. So let's get into this. So line 1, JavaScript store the value of 3 on the identifier called num on memory heap. All right. Here's this we can also here's in this diagram we have the thread of execution. Okay, on the left, right? The global execution context, global execution context, right? And on the left and on the right, the memory or the heap, right? Okay, so second line, all right, we are now storing. So line 2, store the identifier called multiply by 2. Okay, store the identifier called multiply by 2 in memory. Okay, as a function. Okay, store the identifier called multiply 2 in memory as a function. You know, so we are now storing is the code inside of that. Okay, we are now storing is the code inside of that. Exactly, the code inside of that. Line 2. Then next one.
That is a separate thing. We execute code, we take code to run by putting parens by inserting arguments. That is a separate thing. We execute code, we take code to run by putting parens on the end of the name of the code that we save. Perfect. Alright, but for now, what's the other thing that goes to execute a function? Well, we ideally want that code to be a little bit more flexible to work with different data. Or if we want to say it's going to multiply 3 or 7. So we have placeholders for data that then gets inserted when we go ahead and run that code. 2 parts to running a function. One, running its code. The other, inserting actual values as inputs. So when we save the code that's going to later be run, we better have both of those things. Space, code to run. That's the body of the function inside the code braces. We're storing that in here.
Code to run.
The body of the function storing it here. And we better have little placeholders.
Exactly. So here we're storing is the body of that. So line 2, store the identifier called multiply by 2 in memory. So store the identifier. So store in the identifier, because in the identifier called multiply by 2 in memory, the function body, aka the code of that, this set of instructions for that.
But we're awaiting any data to be inserted, and that's the parameter between the parentheses. Okay, and that's also stored in here. 2 things running a function. You better be ready to do code. You better be ready to code. It's saved. Next line, Virginia. What's the next line of code we're going to do after we've saved the function multiply by 2?
Comments. We create a label output.
Excellent.
Assign it to
And off white.
or call or execute.
Aha. Left-hand side first. Declare output is a label. People, this may feel quite trivial when we're here to learn about building LinkedIn from scratch, but I promise you, I have a feeling that if we're going to receive messages at any random time, Sarah Rose's Mac, she wants to get on Twitter anytime, all the time. She's very excited by Twitter. In it comes, that's going to presumably tell Node, because Node can listen in through attribute notation on a feature or a library of C++ code called libnewb that can be aware when an inbound message arrives. Node is then somehow presumably going to tell JavaScript to run some code to look at that message. Because we want to look at the message. So we want to go to write code in our language that looks at the message and see what it's asking for. Well, that sounds like we're going to have to run some code up here later than when we wrote it. How do we bundle up code to run later than when we wrote it? How do I bundle up code? So it may seem trivial, people, functions, but they turn out to be the most important construct of JavaScript. Code bundled up that we're not going to run now, we're saving it to run later. And we're going to do a lot of saving code to run later. By the way, Node here, when we run it later, we are going to manually ourselves put the parens on the end to say run it. I have it.
So for example here. So here we are going to store the instructions, okay, but this is what happened when we do this.
By the way, code bundled up that we're not going to run now, we're saving it.
Exactly. So here we are bundle up code. Okay. So here we are bundle up code that we are not going to need it, and then we do. At some point we're gonna run it. So here we're gonna bundle up code that we don't need it yet, that we are not going to run now, so that we don't need it yet, and we're saving it to run that later. Saving it to run that later. Saving it to run that later. Okay.
To run later. And we're going to do a lot of saving code to run later. By the way, note here, when we run it later, we are going to manually ourselves put the parens on the end to say run it. I have manually insert the input into the argument. I have a sneaking suspicion that Node might end up being the one who puts the parens on the end.
Okay.
Node might end up being the one who puts the parens on the end. Who inserts the input automatically for us.
And then line 3, it will execute multiply by 2, since we are telling to JavaScript we'll execute a 2. How? By putting parentheses at the bottom, or putting parentheses at the end of the by putting parentheses at the end of the label, at the end of the name, right? So line 3 will execute multiply by 2. How? By putting parentheses at the end of the name.
Es que digo, es harto el peso que acarrea, debe ser un par de kilos. Brígido, me imagino. Y uno no vive nada de eso, uno buena, claro. Uno se ahorra todo ese. Buena.
So line 3 will execute multiply by 2. How? By putting parentheses at the end of the name. Right?
That's going to turn out to be the entire paragraph.
So we have a suspicion about how our functions run our code, since Node is the one of putting the values inside of our parentheses, and that is the entire paradigm of Node. Interesting.
Who inserts the input automatically false.
So we have a suspicion about how our function run our code, since Node is the one of putting the values inside of our parentheses automatically for us. Is putting values inside of a parenthesis automatically for us.
That's going to turn out to be the entire paragraph. We'll get to that in a second. For now, let's start off by declaring output. There it is, output, the label is declared. Do we know what to store in it yet, Julia?
Do we know which one?
Do we know what to store in output yet?
Not yet, because we haven't executed.
So it's going to be uninitialized for now, no actual value. Not undefined, because that's an actual value in JavaScript. Compute, thread of x, and we like a mini JavaScript app, like the big one we did. And when we leave, that is what? Output, and assign its output. What's with it?
And this is what happened after it evaluated that. So because we are running a function, it creates now a function execution context.
El tema de...
All right. So
de hola Euler, de hecho se le iba a decir que si el Euler no se conectaba que me ayudaran todos a llamarlo porque le hice como 5 llamadas seguidas. Les mandé por el chat la retro, onda como donde está el Miro y todo, para que lo puedan ver y podamos ahí interactuar.
and I'll make a pause here. So take care. I'll be right back. And we are back with a different setup and clothes. Yeah, I have to do some stuff, right, on the job, but here we are. Right now, so we are now evaluating is this and be able to describe what happened at each one of those lines to understand now the three stuff that JavaScript actually does. First is, well, saves data and its functionality to be used later on, and then use that data by running the functionality on that. All right, and the other features, all right, or the other talent that JavaScript has is that we can have access to the labels or features web API that we can have access to. And this in this case is the node labels. Now, as a way to recap this, okay, so the first line of code is now it store the value of 3 on an identifier called num in memory. Okay, or on memory. We say on because it's huge, vast. We don't know exactly how much it is. And here in this diagram, we have now a thread of execution, which is the global execution, and on the left, and on the right, the memory heap. Okay, so here we actually put that num3 here. But because on the second line we want to store this instruction, this set of this functionality that we want to later on use it, all right. So here we are bundle up. Okay, so here we are bundling up. Okay, so here we're bundling up the code that we don't need it yet. Okay, so we are bundling the code that we don't need yet, and saving it to run that later, which is here. And saving it to run that later, right? So this is line 3. It will execute multiply by 2, and the line 3, if you remember, is this one. Okay, this is when you call this multiply by 2 identifier that we store that and we execute that. How do we know that? By passing now the parenthesis by passing the parenthesis at the end, because here we are now can provide is an input or argument, a value. The suspicion about is how our function runs our code, since Node is the one who's putting the values inside of our parentheses automatically for us. And that's the entire paradigm of Node. Something that we're going to see that later. And then because we are running a function, we create now a function execution context, where this small little example here, like this, all right, it create now this function execution context. Let me actually put it here, function execution context. Okay, to evaluate the instructions inside of the multiply by 2, right? That's one of the reasons why these functions and objects are stored by reference. And this is JavaScript code, so JavaScript won't go back at some point. No, it's going to evaluate line after line, and that's all. So you better have a way to store this reference behind the scenes. So with that, all right.
We just need the function automatically hit the close.
Chill, bro.
Curly brace. Okay, same thing to run a functions code. You're gonna have a little memory that means a store of data. This one's temporary.
Yeah.
They call it local or temporary. I call it temporary. And it's just for inside this function. And when we leave the function, what keyword makes us leave the function?
Return. Okay. So by the time that we leave the function using return keyword, right? So by the time that we leave the function using return keyword, okay, we remove it from the call stack, which is something that you don't mention. That we remove from the call stack, and go back to whatever line of code we need to run. Or we go back to whatever line of code we need to run. Okay, let me actually because we are running a function, we create a function execution context and add that function execution context to the call stack. All right, give me a second here, please.